back to Easy High School Physiology. Today we're embarking on Module 12. We'll be talking about the eye. And the idea here is that the eye is one of the senses. And senses are very, very important to the brain. The brain can't do any actions unless it knows what's going on, both outside the body and inside the body. And a matter of fact, we can take a look at the traditional senses here, of which the eye is but one. So we have seeing and hearing, smelling, tasting, touching. Now, balance and location might be ones you haven't thought about much lately, but balance is very important to the body moving around, especially in sports. And location has to do with where the feet and the legs and the arms and the hands are in relation to the body when it's moving. So we'll be going into that also. These are usually called the external senses. This is information that the brain gets from outside the body so that it knows what to do. We already took a look at the skin, which has to do with touching, and we're going to spend some time today on seeing and the eye. Now, I mentioned that some of the information that the brain needs comes from inside the body, and when we do get to the brain, we'll be talking more about these internal senses that determine heart rate, blood pressure, breathing rate, and body temperature, all very important to keeping us alive. All right, today we're going to take a look at the eye and how we see. And just to give you kind of an overview, we have this fairly large picture here. And we're going to get into detail just in a few minutes, but I want to give you just an overview of what happens here. And it's probably something you've seen before. The light is going to come in from this direction into the eye. It will pass through a number of fixtures or parts that we're going to go over in a minute. It's going to go through the large central part of the eye, and the light will project itself on the back of the eyeball right here. Once that image or that picture lands on the back of the eyeball, excuse me, that image will be changed from light into an electrical message that the brain can understand, and then that message will go through this optic nerve up to the brain for interpretation, to give what the eye is seeing some kind of meaning. All right? So in a way, the eye is very much like a camera. It does not interpret what it sees. It only catches the light and passes that message on to the brain. All right? We'll come back to this picture in a few minutes, but I'd like to go over some vocabulary as we've done before. And again, we're going to not cover this in great detail. Whoops, there we go. But just give you an idea of the spelling and the words that we will be covering. The cornea is the very front part of the eye. It's a clear, hard covering of the eye. If you wear contact lenses, this is the lens would go right onto the cornea and would stick to it. And anyway, we'll get back to that cornea in a little bit more detail. The pupil is the hole through which light passes. And depending on how bright the light is, the pupil can dilate to let in more light or constrict to let in less light. All right. The lens is just behind the pupil, and what the lens does is take the rays of light coming in and bend them or change their direction, if necessary, so that they land exactly on the retina, which is the back of the eyeball. The anterior chamber is just behind the cornea, and it contains a watery fluid that helps bring nutrients to the cornea and the lens and the iris, which we'll see in a few minutes. Also, it takes away waste products. The vitreous is the center part of the eye, made of kind of a gelatin material, and it keeps the eye, gives the eye its shape, keeps it sort of round. The iris is the color part of the eye, so if you have brown eyes or green eyes or blue eyes, it's the iris which gives the color. Also, the iris is the part that can kind of open or dilate or constrict to allow more or less light to come into the eye. Reflection. Reflection is when light bounces off a surface, usually a very flat surface, like a mirror. This is a fairly common word, but the reason I bring it up is that the eye does not reflect anything. But what it does do is refract. This is called refraction. And what refraction means is that when light goes from air into a more dense substance like glass or water or plastic, the light actually slows down and changes direction. And this does happen in the eye, and so we will be talking about refraction. Okay, let's stop there for as far as the vocabulary and take a look at the eye itself. We're going to go back to this picture. Okay. And what we see starting out here, the light coming in with the light rays, and the first thing the light passes through is the cornea. Here's the cornea. Again, it's a clear, hard covering that the light passes through. When light passes through the cornea, because the cornea is denser than air, the light slows down and it starts to change direction. So about 2/3 of the refraction that happens in the eye happens in the cornea. And we'll take a little bit later, take a look at the actual changes of the direction of the light. Next, the light passes through the anterior chamber. Again, this contains kind of a watery substance, similar to plasma in the blood, and it carries nutrients to this part of the eye. Then we come to the pupil. Here's the pupil. This is the opening that the light passes through, and the opening is made possible by the iris, which you can see here and here. And the iris can, again, dilate or constrict to let more or less light come in through the pupil. Okay? Next, coming back here, we have the lens. The lens has little muscles on each side of it, here and here, to change shape as necessary. So the lens can bulge out like this or can flatten more. And by doing that, it helps to change the direction of the light rays coming in, because what we want the light to do is fall exactly on the back of the eyeball on the retina right here. Next, we have called the vitreous. This is just a gelatin, like a jello substance, which gives the eye its shape. In the back of the eye here, we have a layer of cells called the retina, and the retina has the interesting job of changing light into electrical energy, because believe it or not, the only thing that the brain understands is electricity. So the light is changed into an electrical message which goes out the optic nerve here to the brain, so that what the eye is seeing can be given some kind of meaning and interpretation. So those are the basics. Let's take a little bit closer look at some other pictures. Let's see. Which way was that going? This is going toward me, right? Mm-hmm. Okay, we have this picture, and here we see the cornea again out here, the anterior chamber here. Here's the lens here, the vitreous humor here. Notice the vitreous humor has a lot of blood vessels, and the blood vessels also are on the retina. When the doctor looks into your eye with a special light, they're looking at the retina and they're also looking at the blood vessels. Gives them an idea of the health of the eye. Here's the optic nerve here. Okay. I want to go back to a picture that we looked at before, because on the back there was something I wanted to show you, and that's this picture here. This is a picture of the iris. Now, we're looking directly straight into the eye from the front. So here's the pupil, which is nothing but a hole, like a hole in a donut. And this is the iris. Notice the colors. This person would have a red eye, okay? So the iris is hooked up into muscles in a way that the iris can pull back like this or go forward like that. If it pulls back, the pupil is bigger and more light comes in. If the iris goes constricts more, then it allows less light to come in. Obviously, if you're outside in a very bright day, your pupil is going to be constricted. You don't want a whole bunch of light coming in. But if you walk into a dark room, for example, then you want your pupil to open up as much as possible and let quite a bit of light come in. The pupil itself, the diameter of the pupil can be anywhere from about 2 millimeters in a dark situation to about 8 millimeters diameter excuse me, I got that wrong, the other way around. In a dark situation where the pupil, the diameter of the pupil is large, that would be about 8 millimeters. On a very bright day, then the pupil would close down to about 2 millimeters of light coming in. Okay. Here's a different picture. Here we have the cornea, again, out here. By the way, if you ever get a speck of dust or dirt in your eye and it rubs up against the cornea, you will really feel it, because the cornea is very, very sensitive to those kinds of pain. And you want to get that piece of dirt or dust out of the eye right away. Here's the anterior chamber, full of kind of a watery substance. Here's the pupil here. The iris, this is one part of the iris coming here and another part of the iris coming here. Here's the lens. Remember, the lens can change shape, allowing the light to refract either more or less, depending on what you're looking at and how your eyesight is. By the way, in older people, you probably notice that they have a difficult time looking at things up close. And what happens is, with older people, say over about 45 or 50, their lens becomes a little stiff, and it's hard for it to change shape. And so those people usually have some kind of reading glasses or something that helps them look at things very close by. Okay. I use this picture because it shows it with a little bit more clarity. I know it's upside down. My technician's son just told me it was upside down. I'm doing this because I want all the eyeballs to look at it in the same way. So, thank you. I should have told you that before. So here is a little bit better view of the cornea, anterior chamber. Here's the iris. Here's the lens. Here are the muscles that pull on the lens, making it either bulge like this or look a little bit more flat like that. Okay. All right. You notice the eyes are always watery, and uh, that's part in tune for the anterior chamber, but it also has to do with lacrimal glands, the tearing of the eye. The tearing, of course, keeps the eye moist, it keeps the eye lubricated, and there's also a substance in the tears that help to kill germs. So very, very important, these so-called lacrimal glands that secrete tears, not only to keep our eye healthy, but also, of course, under emotional stress. At this time, I'd like to introduce a few more of our vocabulary words that we will be talking about. The retina is the very back part of the eye. It's the layer of the eye that contains the special cells that change the light into electricity. The optic nerve is the special nerve cells that send the message back to the brain what the eye is seeing. Blind spot. There's a place on the retina where you can't see anything, and this is where the optic nerve comes into the retina, and there are no special cells. They're called photoreceptors there because the nerve is leaving the eye. So if you turn your head to just a certain position so the light is landing on the optic nerve, that's a blind spot and you can't see anything. Myopia. This is the fancy word for having a problem with your eyes that you can't see far away. Hyperopia is a problem with your eyes where you can't see things close up. Astigmatism is probably the third of the eye difficulties. This has to do with mainly your cornea not having a smooth shape, and it's kind of bumpy, so that when the light comes in, it kind of jumps around in different areas and it doesn't land exactly on the retina. All of these, by the way, myopia, hyperopia, and astigmatism, can be corrected with glasses. Okay, very good. I mentioned before the idea of reflection. This is something we're all fairly familiar with. The light comes in and it lands on a surface like a mirror, and the light bounces off. Usually, with whatever angle the light comes in, it also bounces off at the same angle on the other side. We see that here with light coming in at this angle, whatever it is, and it's bouncing off a mirror, and it bounces off at the same angle on the other side this way. If the light came in exactly 90 degrees to the mirror, which way would it reflect? What do you think? It would reflect exactly back out the same way. This is reflection. Now, the eye does not reflect, it refracts. Let's take a look at refraction. Here we see a light ray coming in from the air, and it's entering, well, this could be plastic or it could be glass, it doesn't matter, but it's a substance that's more dense than air. Because it's more dense, it has more matter. And as the light comes in and runs into this matter, it slows down. As the light slows down, it changes direction. Notice how it was going this way, now it's changed direction. But as soon as the light goes out of this dense material back into air, it resumes the same direction it had before. But you can see the light was bent for a certain amount of period here. This does happen in the eye. This is very interesting. Let's say you're looking at a tree that's quite far away, let's say 50 or 100 feet away. So the light rays are coming or bouncing off the tree from like the sun, and they're entering the eye over here. Oops. And of course they go through the cornea, and the cornea bends the light by refraction a little bit because we want the light to fall exactly on the retina back here, right? And then the light goes through the lens, and the lens also refracts the light a little bit. And the whole idea is for the light to land exactly on the retina right here. This should give you 20/20 vision, very normal vision, okay? But notice, look at the image on the back of the eye there. What happened to the tree? Well, it's upside down and it's backwards. Everything you see that's outside here ends up on the back of your eye, upside down and backwards. So, how do you see that the correct way? Well, when this image is sent to the brain itself corrects the image and brings it back the way it should be. This is learned when you're a baby and when you're a child, and your brain just adjusts to all of this upside down information, okay? Let's look at some of the difficulties that eye can have. Here we see a normal eye. The shape is normal, so when the rays of light come in and are refracted by the cornea and the lens, the image falls exactly on the back of the retina. This is very good, and this person has 20/20 vision. Let's look at this person. Okay, this person, the light rays come in, they're refracted again, but instead of falling on the retina, they fall in front of the retina. This person has myopia and has trouble seeing things far away. They're blurry. Okay. This person, here the light rays are coming in and they're falling behind the retina. This person has hyperopia and cannot see things close up. All right. Now, what can we do about these problems? Well, scientists for a long time have known that if you get some glasses that help to refract that light a little better, that we can get the light to land exactly on the retina. This person who has myopia, the problem is the eyeball is too long this way. It's just born that way. All right. So this person cannot see things far away. He goes to the doctor, and the doctor gives him glasses that are shaped like this. This is called a concave lens. And what happens is it refracts the light so that it falls exactly on the retina, and this person has 20/20 vision. Okay? For the person with myopia who cannot see things close up, a different kind of lens called convex lens is used. It looks like this. And what it does is focus the light more so that instead of falling behind the retina, it falls exactly on the retina. And this person should have 20/20 vision. The problem with this eyeball is you can see it's not long enough. It's shaped too bulging out this way. Okay? So this is how doctors called optometrists can assess your eyesight and give you glasses. By the way, when you go to the eye doctor, sorry this picture's so small. You probably remember looking at an eye chart like this, all right? And the normal person has 20/20 vision. Now, what does that mean, 20/20 vision? Well, it's very simple. Whenever you look at an eye chart like this, which is standardized, by the way, everyone stands 20 feet away, exactly 20 feet away. If you can look at this line right there and read it from 20 feet away, you have 20/20 vision. That means you can see from 20 feet away what a normal person can see from 20 feet away. But let's say you have 20/40 vision. What does that mean? Well, that means that a normal person can see this line at 40 feet away, but you have to be 20 feet away in order to see it because your eyes are bad. All right? Let's say you have 20/60 vision. Then that means that a normal person can see this line 60 feet away, but you have to be 20 feet away to see it. Okay? Simple as that. Most of you have probably seen before that white light, when sent through a triangular prism, breaks the light into its many wavelengths and forms the colors of a rainbow: red, orange, yellow, green, blue, indigo, and violet. All right. Now, these colors can all be seen by the eye, not because they're broken up, not because white light is broken up, but because certain cells in the retina are sensitive to different wavelengths of light. And let's take a look at a layer of the retina here. And we can see this is the front of the retina, this is the back of the retina, and we have photosensitive cells called rods and cones. Kind of hard for me to see because it's so small. Some of these are rods and some of these are cones. The rods are sensitive to dim light and also to black and white. The cones are sensitive to color. So either way, whether you're receiving black and white images or color images, the retina will take that light, convert it into electrical messages, and send those messages to the brain. This is an interesting picture. Wait a minute, I'm going to turn this around because we've always had the eyes coming from this direction. Sorry about that. So here's the right eye, here's the left eye, okay? And here are the nerve pathways that those messages take. Part of the optic nerve goes back this way, part of it goes to the left part of the brain, and part of it goes to the right part of the brain. The same thing with the left eye. Some of the optic nerve goes to the right side of the brain, some goes to the left side of the brain. This is the back of the brain here, all right? And this is where the image is seen or looked at, all right? And once that happens, the message is also sent to other parts of the brain, which determine size, distance, and meaning of what you're looking at, all right? So there's actually a crossover here in part of the brain where the left eye, part of the left eye message goes to the right brain, and part of the right eye message goes to the left brain. When we get to the brain, we're going to be talking more about this area in more detail. Here's something fairly obvious, because you have two eyes, each eye sees an object a little bit differently than the other one. The left eye is going to see a little bit this way, and the right eye is going to see object a little bit this way. This is called binocular vision, and what it allows you to see is depth, how far away something is, all right? This object looks like it might be 2 or 3 feet away, but objects can be much further away, and having two eyes gives us depth perception. One more picture that's a little bit different, showing again the nerve pathways that the optic nerve takes, right eye, left eye. Here's the crossover here, going to the back of the brain here. Here's the crossover going to the back of the brain here. By the way, the back of the brain was known for a long time to be the center of sight, or the sight center, because of accidents. Hundreds of years ago, if someone got hit on the back of the head here, and they lost their eyesight. So scientists put two and two together and figured there must be something in the back of the brain that helps with eyesight. And they were right. Okay. Okay, just a couple more things. I'd like to come back to this picture. I'd like to talk about LASIK surgery and also talk about astigmatism. Astigmatism is just a funny word, meaning that the curvature of the cornea is not smooth and regular. It's kind of, for some reason, it's bumpy, irregular. So when the light rays come in, instead of just going straight, they kind of bounce off and go in different directions. This is different from myopia and hyperopia, which has to do with how far things are in the eye. This has to do with the curvature of the cornea. Astigmatism can be corrected with glasses, with lenses, fortunately. So, now the last thing, and I didn't get a chance to do a vocabulary on this, so I'm going to do it right now. And I'm going to introduce this word, because you've probably heard of it. It's called LASIK surgery. Okay? This is where the medical doctor, called an ophthalmologist, does an operation on your eye. And this corrects for myopia, when you can't see things far away. What the ophthalmologist surgeon does is he looks at your cornea here, all right? And if the cornea is thick enough, he'll be able to go in with a laser and take away parts to kind of smooth it out so that the light coming in will refract in a much better way and land on the back of the retina. It kind of takes the place of glasses, all right? Not everyone can have this done. It depends on the thickness of the retina and a few other items. But millions of people have had this surgery done, and it's very well accepted. It's called LASIK surgery. The first two letters stand for laser assisted in situ, and then it's a real fancy name. But anyway, the operation is on the cornea itself, and it shapes the cornea so that the light rays land exactly on the back of the retina like they're supposed to. Okay? All right. Well, that pretty well does it for the eye. Our next module, we're going to take a look at the ear and hearing, and I hope you'll come back and join us at that time. This has been a pleasure to go over the eye with you, and I hope to see you again. This is Dave, signing off. Goodbye.